So just to give you some practice in finding a maximum value m, so that's what our goal is here. These problems become very easy when you understand what the goal is. And the goal is just to find some maximum value m, such that the absolute value of f of x, because sometimes f of x might be greater than the polynomial or less than the polynomial at those particular values, and we just want to be able to find that maximum distance. What's that maximum error? So the error is always going to be in terms of, or the maximum error is always going to be in terms of a positive number, and we can guarantee that positive number by taking the absolute value of this value that we get. So f of x equals e to the x. So let's just say we just took a polynomial and we used it to approximate the function, and the n plus first derivative happens to be e to the x, and we're going to evaluate the n plus first derivative over this interval. Okay, so once you find that n plus first derivative, look at its graph. Okay, and when you look at the graph of e to the x, we know what that looks like. Looks like that. Okay, and then look at the interval. When you look at the interval from -3 to 3, we realize that since e to the x is increasing over the entire interval from -3 to 3, we know that its maximum value must be at the endpoint on the right-hand side. So e to the x is less than or equal to, right over here, if we continue with that, e to the third power, right there, right? If x is equal to 3, then e to the third power is how high that value is, and that's as high as that function e to the x can get on that interval. So e to the x is less than or equal to e to the third power, okay, whatever that is, on that interval, on the interval from -3 to 3. Okay, so therefore that m is equal to e to the third, and that is what you want to find, e to the third. The rest of it is easy, and I will explain how to do the rest of it, but first thing I want to do is get you guys some practice in finding the maximum value, finding that m. That's a, think of that m as the magic number. Okay, so then I encourage you to try numbers 2 and 3 on your own before you watch me do them. Just put a little thought into those, and the better you are at graphing, the better you are going to be in this section. Okay, so pause the video and give these a try on your own. 1 over x plus 1, we know that -1 is a vertical asymptote, and 1 over x plus 1 looks something like, where's my blue? Looks something like this, comes down there like that, and it goes over there like that. So that's what 1 plus x, or 1 over x plus 1 looks like. And on the interval from 0 to 2, we can see that there's 0, 1, 2, and we can see that the maximum value that this function can be is right there on the interval from 0 to 2. You can see it's a decreasing function over this interval here from 0 to 2. So therefore at the beginning of the interval is where this function will reach its maximum value. So 1 over x plus 1 is less than or equal to 1 over 0 plus 1, which is equal to 1. Okay, and that is equal to your m. So let's be consistent with how I wrote that above. So I don't know what I'm trying to do there. Therefore, m is equal to 1, and there's your m. Okay, so maybe you didn't pause the video, maybe you watched that one, but pause the video now and try number 3 on your own. Okay, so number 3, 4 times the sine of x. Typically when you see the sine of x, you just replace that with a 1, but just be careful that you're not that you've got an interval that contains in which the sine of x can be equal to 1. In other words, 4 times the sine of x, you should remember from pre-calc honors that 4 right there represents the amplitude. And if you ever get stuck, just make an XY chart. Plug in 0, plug in -2 pi, plug in 2 pi, plug in the endpoints, plug in 0 somewhere in the middle, and see if you can get a high value, see if you can remember what the graph would look like. If you plug in 0, sine of 0 is 0. So 1, 2, 3, 4. So if this is 2 pi, you should remember that the period of the sine function is 2 pi, and so this should go all the way up to when x is equal to pi over 2. Plug that in as well. Now when x is pi over 2, the sine of pi over 2 is 1, so we get 4. 1, 2, 3, 4. And the actual graph would look like this. And I come down there and go like that. So that's what the graph looks like. Where we can see that in between negative 2 pi and 2 pi, the graph can get as high as 4 units. So at the negative 2 pi, it's 0, 0, 4. And again, like I said, the better you are at graphing, the better you're going to be at this in this section. So we see that, let's use green, we can see that 4 times the sine of x is less than or equal to 4. It can be as high as 4, it doesn't matter how low it can go, we just want to know how high it can go, and therefore our magic m is equal to 4. Okay, so hopefully that makes sense, and in the next video we'll actually do some problems involving the Lagrange error bound and finding actual boundaries for our error.